For the standardization of the diprotic acid, we're going to have a titration setup similar to what we've done in the past with a burette filled with a standardized solution of sodium hydroxide. But we're also going to have a little bit of difference. So first of all, because we're going to need a pH meter, we're going to use a beaker which has a wider mouth, and we're also going to use a stir plate with a magnetic stir bar in the beaker to keep the solution moving and dissolving as we do our titration. So this will help speed things up. This is the pH meter we will be using. It is wireless. And notice that there's a little bottle attached to the bottom of this. This is a buffer solution, so we need to be sure that we rinse off that buffer solution before adding it to the beaker. The reason for this is that the buffer solution is set at a pH of 4 and will be useful in keeping the pH near 4 for this particular pH probe. But we don't want to take droplets of that pH 4 solution and add it to our solution, which at the moment has an unknown pH. So we're going to rinse it off with deionized water and then place the probe into the clamp. The bottle is a screw top, so we're going to leave the cap attached to the pH probe. Make sure you set the bottle somewhere that neither you nor your lab partners will knock it over. And then have a waste bottle or waste beaker that can collect the runoff, and you'll just rinse the probe with a little squirt of deionized water. At that point, you can attach it through the clamp into the liquid. We want to keep the bulb wet, so make sure it is below the level of the liquid, but also make sure that you don't have it knocking against the magnet that is in the water. So don't rest it on the bottom. The last thing to be careful of is not to knock the burette valve while you are inserting the pH meter, because you don't want to add any of the NaOH before you have started recording your volume. The pH meter may need to be turned on in order for the program Graphical Analysis to be able to pick up the pH through Wi-Fi. Before collecting our data, we need to set up Graphical Analysis so that it will collect the data properly. You'll notice on the bottom it says it's going to collect in seconds. We don't want time-based, so we're going to need to go to the lower left-hand corner and select the icon that says Mode. When we click on this, we'll see a menu where we can change from time-based to event-based and change the event name to burette because we're going to be doing a burette reading, and the units to milliliters. We're also going to click Average the sensor readings over 10 seconds so that it will take an average reading, and this will get rid of any fluctuations that might occur in the pH reading. To start collecting data, first we will hit the Collect button. This won't actually collect any data, but it will get us ready to hit the Keep button when we want to collect our data. Hitting Keep will tell the computer to start averaging over the 10-second time period the pH that we want to collect. While it is averaging over those 10 seconds, we can be reading the burette so that we're ready to record that data when the screen pops up. We now have our first data point recorded, and you can see it on the lower right-hand side. The graph won't be very meaningful until we have more data points collected. And as they are collected, they will spread more across the screen so that we can see what the shape of the curve will be. Initially, the pH will change very slowly with larger additions of NaOH. So we can add NaOH a milliliter or so at a time and still have good data. After a few additions of sodium hydroxide, it looks like our graph is going to be linear. This is not actually going to be the case. It's going to start changing its slope soon. So now that we are a few milliliters in, we're going to add smaller amounts so that we don't miss the important change in slope. After adding nearly 15 milliliters, you can see that it is clear that this graph is not linear at all. There are different changes in slope, and those are going to become important later. Now we're going to get to a part where the slope is rising rapidly. Now that we've collected all the data, you can see the general shape of the curve, and you'll also notice there are a few data points that look like they're out of place, where I entered the wrong volume. This happens. We can correct this by selecting the data point, which will appear in the data table, and then deleting that data point by cutting it. Once it is cut, the dot will disappear from the data, or from the graph. So we can do that with each of the data points in order to clear up the graph. As I was doing the data collection, I realized that I was doing this, and you'll notice that there are two different measurements of volume for the same pH because I was accounting for this. Now that this part of the graph is cleaned up, we want to make sure that it is labeled properly. We need to go and give the graph a title by clicking in the lower left-hand corner. This is unknown E, so I'm going to label it as unknown E and have the title at the top of the screen. I can also change the axes so that the range is covering the range that is important to me. I want to see the entire pH range, so I've made this from 0 to 14. We want our horizontal axis to be the actual volume and not just the burette reading. So we're going to add an additional column by highlighting the burette column and adding a manual column. In this manual column, we'll put the initial volume of the burette. So we'll need to find that initial volume, and then we will use that down the entire column. Next, we will need to add an additional column that will calculate the difference between the burette reading and the initial volume. So we add a calculated column, call it the volume of the sodium hydroxide in units of milliliters. And we can only read this to 2 decimal places, so we can change the decimal reading to 2 decimal places. And then we can insert the expression of subtracting the 2 columns, making sure that we're subtracting the initial reading from the burette and not the other way around. We can find the second equivalence point by taking the most vertical portion of the graph and selecting the 2 data points that surround this vertical portion. For the first equivalence point, we will need to use the first derivative. So we're going to add a calculated column and call it the derivative of the pH. We won't have any units for this, and we can just leave the significant figures or the decimal places at 3. we're going to take the derivative of the pH versus the volume that we've been titrating. And so we can see this derivative here. The first equivalence point will be where the derivative is highest, because this will be the most vertical portion of the graph. It is a subtle change, so you will have to look at the numbers in the region that is halfway between our second equivalence point and the origin.